Okay, so working example 12 here, and in this problem, we've got to come up with this empirical formula, but specifically a combustion of an alcohol. Okay, so an alcohol is going to be some combination of carbon, hydrogen, and oxygen, and if we add our O2, it's going to give us some carbon dioxide and some water. Now, what's important here is that we know that the carbon dioxide value is basically going to produce 1 mole of carbon, where the water value is going to produce 2 moles of hydrogen. And so we're going to use that information to help us out, this 1 mole of carbon and 2 moles of hydrogen. Because if we can get moles of carbon and moles of hydrogen, we can convert them to grams, and we can subtract from the starting value, and whatever's left over has to be oxygen, because this only has carbon, hydrogen, and oxygen in it. Okay, so the problem starts the same. It's an empirical formula problem, so we're going to start the same by converting into moles. And so we only have 2 values, and we're going to use those. We have a carbon dioxide value, and that's 0.561 grams of our carbon dioxide, and that's going to go ahead and go into moles. Standard stuff, always go to moles for these empirical formula problems. And we're going to do the same thing with the water, and that one's going to be the 0.306 grams of the water, and it also is going to end up going to moles. So again, standard stuff, and there we go. So we're going to run this through a calculator, and we're going to get we're going to go 0.0127. Now you can run it through a calculator, but that's what you're going to get with the 3 sig figs. And then we're going to do the same thing down here, and we're going to get 0.0170 moles. Now, the top one's fine. So this one is good to go. This is fine, because that's going to end up being moles of carbon, because right here we said each CO2 has 1 mole of carbon. So that's moles of carbon. So we're fine there. So we can just go ahead and write that down here, that we have 0.0127 moles of carbon. This is the one you have to manipulate. This has 2 moles of hydrogen in each water. So because this is water, we're going to have to go ahead and multiply this one by 2. And then that's going to give us our moles of hydrogen, because right here, see the 2 in the hydrogen there within the water. So 2 moles multiplied by 2. Run that through your calculator, and you're going to get 0.0340 moles of hydrogen. Okay, now what we have to do is we have to convert both of these back to grams. So we're going to go back to grams, because we want to know how many grams of carbon we had and how many grams of hydrogen we had, because the leftover has to be oxygen. If we know how much oxygen we have, we can get moles of everything, and we can go ahead and do the math. So I'm going to clean this up, and then we're going to do that piece. All right, so I cleaned it up, and now we're going to turn these back into grams. Now remember, they were carbon dioxide and they were water. Now they're going to be going into a hydrogen component, and they're going to be going into a carbon component. So here we go. So we'll start with the carbon, 0.0127 moles now of carbon. But we're going to turn it back into grams. So it's going to go 12.01 grams for every 1 mole. And we're going to do the same thing for the hydrogen. So 0.0340 moles of the hydrogen. And it's going to also be getting turned into grams. Now, the value is going to be 1.01. Not 2.02, because it again is in a compound here. If we look, this is going to be in a compound, and so we're not going to be doing anything with diatomics. So just do that. So I ran the math through, and this is what we get. You get 0.153 grams of carbon, 0.0343 grams of hydrogen. So we need to add these now, because we're trying to compare again to this value here, and we want to know how much of our sample is hydrogen and carbon, because whatever's left over has to be oxygen. So what we're going to do is we're going to just add these up. So take 0.153 and add that to your 0.0343. I'm going to slide this down here, and that's going to equal 0.187 grams. Now this is combined carbon and hydrogen. So what this value is, it's combining the carbon and the hydrogen. So whatever is left over has to be oxygen. So what we're going to do is we're going to take the starting number that they gave us, and the starting number they gave us is right here, 0.255 grams of the alcohol. And so we're just going to go 0.255, and we're going to subtract the 0.187. Whatever is left over has to be oxygen, because we're taking out the carbon component and we're taking out the hydrogen component. Whatever left has to be our oxygen component. So when we do that, we're going to get 0.068. So we get 0.068 moles, sorry, not moles, grams. We're going to convert to moles, not moles yet, grams of oxygen. All right, so I'm going to clean this up and get a little space, but what we're going to do now is we have to convert these grams of oxygen right here into moles of oxygen so we can compare it to our moles of carbon and our moles of hydrogen. If we have moles of all three, we can divide by the smallest, and then we can get a formula, standard empirical formula kind of stuff. So I'm going to clean this up, and we're going to come back. So now oxygen is going to go back into moles again so we can compare. So I'm going to take 0.068 grams of oxygen and can convert it to moles. Mole on top. And this is going to give us a value that we can now compare to. So we need everything in moles. When we have everything in moles, we're going to be able to compare all of our values. So when you do this, you're going to get with probably should have 3 sig figs, but this is okay. So we're going to go 0.00425. Really should have had a 0 there, but that's fine. Okay, so we're going to go ahead, and now that we have moles of oxygen, we have moles of everything. We have all three of our chemicals. They're now all in moles, carbon, hydrogen, and oxygen. We have everything we want. So now it's standard empirical formula. So remember empirical formula, it's convert to moles divided by the smallest. So if I'm comparing my values here, then this one here versus this one here versus this one here, the 0.00425 is the smallest. So we're going to end up dividing them all by the smallest value. So we'll clean this up real quick, and then we're going to go ahead and do that. And then hopefully it'll give us some clean values that we can use for our final formula. Okay, so I cleaned that up and did that real quick just to save a little time on the video. So again, we are dividing everything by the smallest value, which was right here. This is the smallest of the three. So everything is getting divided by that value. So when I do that, I get a value of 1 for my oxygen component. Here's my carbon component. I got a value of 2.99. We're going to go ahead and make that 3. That's for the carbon component. And then the hydrogen component got a value of 8. So nice clean numbers. Don't have to find a common multiplier. So I can just go ahead and I can create my final formula, which would be carbon, and that's going to get a 3. And then my hydrogen, which is going to get an 8. And then my oxygen, so C3H8O. And so that is my empirical formula when I'm looking for my mystery alcohol, and that would be your final answer. Now, a lot of work here. So IB has stressed this in the curriculum, so it's likely that this would come up. A couple of things to go over just before we stop is that when you run through all of these, you are going to be doing extra work, and the extra work is really just to get how many moles of oxygen you have. So all of the work we did was just to subtract the carbon and the hydrogen mass from the starting mass so I could figure out how many grams of oxygen I had so I can go to moles. Once I have all my components, it's not very difficult. Okay, so now what you should try to do is we're going to go ahead and attempt this example 13. And so try example 13, see if you can get the answer, and then I will film the process of getting the answer to example 13 so you can double check. But again, when you're doing this on your own, when you're doing this at home, you do want to try these. Do not just look at the answer.